The topic of this video is latitude and longitude. What are they and what are some of the details? So just like in math class, you had x and y coordinates, and you could specify a point on that coordinate system using two numbers, x and y. We can also use longitude and latitude to specify a location on the surface of the Earth. Okay, with the usual convention of north being at the top of a printed map, longitude is like the x-axis and latitude is like the y-axis. So north, east, south, west, going clockwise around the compass dial there. So if you're not already familiar with that, sometimes people use a little mnemonic device. The one I've seen or heard most often is never eat shredded wheat or never eat soggy waffles. I guess soggy, we'll go with the soggy waffles. So never eat soggy waffles, north, east, south, and west, going clockwise. All right. And now when we talk about longitude and latitude, rather than using plus and minus signs like we do with x and y number lines and coordinate axes, we're going to use north and south for latitude and east and west for longitude, with the west being like negative and south being negative latitude. And so sometimes written as pure number, the plus and minus signs will actually be used. But in general, certainly in conversation, we'll tend to say north or south or east or west. So here is a wonderful diagram from the folks at Encyclopedia Britannica, which is really getting at the definition of what latitude and longitude are. So imagine you have the Earth, and you slice into it all the way to the center. Then the longitude is the angle, either east or west, from the prime meridian. So if we come over here, this is the longitude angle from the prime meridian. Now the prime meridian is a line that runs from the north pole of the Earth to the south pole of the Earth, running through the Royal Observatory in Greenwich, England. And in other words, basically London. And the reason it's there is because astronomers were, a couple hundred years ago, the folks who were really intimately involved with map making and timekeeping. And so it became natural to sort of take the reference from the place where the telescopes were being used for timing the motion of stars across the sky. That was used to determine things like longitude. And the reason it's London is because England was a global superpower in the 1800s, when it was decided that this would be the 0 point for longitude for maps all over the world. That really irked the French. The French really wanted 0 degrees longitude to run through Paris. But in the end, the international agreement came out to be that it was through London. And so that's longitude. And then latitude is the angle north or south from the equator. So here's the latitude angle. And so latitude in this sense is less arbitrary. See, the 0 point for longitude is arbitrary in the sense we had to pick London. Whereas for latitude, there is a natural 0 point, that being the equator, the line on the Earth that's halfway between the poles. So there's no arbitrariness there, whereas we as a society had to agree on 0 degrees longitude to be Greenwich Observatory. And in this particular diagram, the example given is New Orleans. New Orleans, its latitude is about 30 degrees north and 90 degrees west longitude. In other words, this angle is 90 degrees west from the prime meridian. Here's another example, less complicated diagram, but this doesn't have the cutaway. So this is how you're usually going to see these diagrams, where it's just, you got the Earth, and So longitude being angle, in this case west, this is going to Washington, D.C., latitude angle north from the equator. Now you can tell from this is the equator of the Earth. So there's 1, 2, 3. Now from the equator to the North Pole is going to be 90 degrees. So in other words, each one of these lines is 30 degrees. And so in fact, the latitude of Washington, D.C. is about 38 degrees north, and 30, 60, more than 60, about 77 degrees west is, so 38 degrees north, 77 degrees west is the approximate, to the nearest integer degree is the location of Washington, D.C. Unlike in a two-dimensional coordinate system, your x and y coordinates in math class, where you just have this grid of lines with on the curved surface of the Earth, the globe of the Earth, the lines of longitude are going to converge at the north and south poles, and the lines of latitude, on the other hand, run parallel to the equator. In fact, you'll hear people refer to the parallels, the 45th parallel or the 52nd parallel, and that's referring to a line of latitude. So quick ABCD poll here. I want you to think about this. What would be the latitude of the North Pole of the Earth? So ignore the red arrows, that's still pointing to Washington, D.C., but up here at the very top would be the latitude of the North Pole of the Earth. And did you think about it? And I'm hoping you picked D, 90 degrees north. What's the latitude and longitude of Timbuktu? That's in Mali. And so Timbuktu, and I'm giving you some choices here. I'm not asking you to estimate. I'm just distinguish between these wildly different choices. And what do you think it is? Hit pause if you need to think. And then I am hoping that you have chosen answer I actually have to look at it here. Yeah, here's the prime meridian. The answer is B, because we're a little bit west still from the prime meridian, and about halfway between the equator and 30 degrees latitude, so 17 degrees north. Now, those examples, those three examples were just to the nearest integer degree. We can be more precise, of course. So I pulled up Google Maps, High Point University campus, and I clicked on the Chick-fil-A in Slane, and the latitude and longitude then appear at the top of the map. And so the Chick-fil-A, for future reference, is at a latitude of 35.97096 north degrees and a longitude of 79.9922378 degrees west. And that is where the Chick-fil-A is in Slane on the surface of the Earth. Now, there are a few other landmarks that you should know about that are key in astronomy, more so than the Chick-fil-A location. We've, of course, talked about the equator. By definition, the equator is 0 degrees latitude. The North Pole is 90 degrees north latitude. The South Pole is 90 degrees south latitude. But then there are the tropics and the Arctic and Antarctic Circle. And the reason for the tropics and the Arctic and Antarctic circles has to do with the tilt of the Earth. And that's a separate topic, separate video, separate discussion about the seasons. But since we're talking about latitude and longitude here, I can't let it pass without mentioning that over the course of a year, the sun is variously over the different latitudes of between the Tropic of Capricorn and the Tropic of Cancer. And that's because the Earth's axis is tilted by 23.5 degrees from being perpendicular to the Earth's orbit. And so this particular diagram is showing kind of like a side view. So the sun is way off to the side, and so the light's coming from the left in the diagram, and the sun is directly overhead in this diagram, is directly above the Tropic of Capricorn. And so to people on the Tropic of Capricorn, the sun would be, at noon, would be directly, perfectly at the zenith, straight overhead. And so this is the longest day of the southern hemisphere summer. So it is the summer solstice in the southern hemisphere, and it's the winter solstice for the northern hemisphere. In other words, on the calendar, this is December 21st. And so if we jump ahead to the solstice for the northern hemisphere, this is where the Earth is tilted, or the northern hemisphere is angled towards the sun, and the southern hemisphere is angled away. This is now where at noon on the Tropic of Cancer, the sun will be directly overhead. And so I do have a question here for you to think about. Can the sun ever be directly overhead here in High Point? Well, the Tropic of Cancer is at 23.5 degrees north latitude, and you saw previously that High Point is 30-ish degrees north latitude. So no, the sun can never be directly overhead here in High Point. And the last two things I'll mention, I'm going to jump back to the previous slide. The Arctic and Antarctic circles, the 66.5, that is 90 degrees minus 23.5. So that's where the 66.5 comes from. And so this is the region on the Earth on, in this case, December 21st, okay, so the northern hemisphere winter solstice, where the sun will never rise above the horizon. So 24 hours of no sunlight on December 21st. And whereas in the Antarctic Circle on December 21st, anywhere inside that circle, the sun is up for 24 hours a day. Whereas we jump forward to June 21st, it's reversed. In the Arctic Circle, it is daylight 24 hours, and it is nighttime for 24 hours on June 21st in the Antarctic Circle. So that is a quick introduction to latitude and longitude, and just some important background information as we talk about seasons and how, especially how your location on the Earth affects what you see in the sky as far as how things move in the sky.